Hi students, we're going to extend on our work from the fundamental theorem of calculus and we're going to use definite integration to work out how to find the area of a region between two curves, and this is the first video. Basically it can be summarized by this pattern here, which shouldn't be a shock because we've learned that with some of our regular mathematical methods it's a property of integration. So what we do is apply that, and we know that basically the integral of a difference of two functions can be is the same as when we evaluate the two definite integrals separately for the separate functions and then find the sum second instead of first. And that's basically what this is about, and that will give us the area between two curves. So the region you can see there in that brown color, okay, and we have this is when f of x is greater than or equal to g of x. That's the context we're looking at. Certainly in this video that's all we're looking at, and it's over some interval inclusive. So if we look at the interval from a through to b, you can see that that area there is in the interval, it is that area there in the brown where my cursor is. So bearing in mind that this is actually quite useful in a lot of ways, it will also underpin some of the work we're going to do in the near future, such as a volume of revolution and things like that too. So this is fairly important stuff. So we'll start with a fairly straightforward one. Find the area between the curves y equals square root of x and y equals x squared. Now you can get your graphics calculator, and it's probably a good idea if you're allowed to use it in whatever situation you've got. If you can use that, you do get a sketch between them. Now we do need that sketch, but usually in most tasks require you to do it algebraically or analytically by hand. So we'll do that too. So what we want to do is find the intersection points, is what I'm referring to first of all. So we want to look at where those two cross over. So we want to know when root x equals x squared. We're going to solve that. So what we'll do here is square both sides. So if we square the left-hand side, we get x, and square the right-hand side, we get x to the power 4. So let's get them both onto the same side. We get x to the 4th minus x equals 0. We can factorize that. We can take a factor of x outside of x cubed minus 1 equals 0. Null factor law, x equals 0, or if we have x cubed minus 1 equals 0, we would have x cubed equals 1, so x will equal 1. So the curves intersect at x equals 0 and x equals 1, so that gives us the interval is from 0 to 1 inclusive. Oops, I didn't write my 1 in there. So square brackets 0, 1. And that matches the diagram. Okay, now note that we said f of x is greater than or equal to g of x. So our f of x in this one will be root x. Now g of x will be x squared. Okay. Now this is where we apply what we saw at the beginning of the video there. So either way you look at it, you'll get the same answer. So if we want to split it into parts, we look at the integral of root x between 1 and 0, which is the integral of x to the half dx between 1 and 0, which comes out as x to the 3 over 2 times the reciprocal of its new divisor there, and that's between 1 and 0, which is pretty easy to evaluate. And when we sub in 1, we'll just get 2/3. When we sub in 0, we just get 0. So that part's 2/3. Do the same with x squared. It's pretty easy by now. Well, it would help if I drew it a little bit more neatly. That's an x squared. I apologize. And actually, I don't need to write that again. So we evaluate that. We sub in 1, we get 1/3. Sub in 0, we get 0. So we would say the area, something like, you could call that A2, A1. So area is A1 take A2, which is 2/3 take 1/3. So we get 1/3 units squared if we're talking physical area. That's essentially it. Or alternatively, you could look at it as this is nothing different. You're really just looking at it in the form of the second part of the relationship we saw at the start of the video. Very much the same thing. So you can see probably already the calculations are going to be the same. Like so, and we sub in 1 and sub in 0. So we sub in 1, we get 2/3 minus 1/3. Sub in 0, we get 0 minus 0, and we get 1/3. And if we're talking physical area, 1/3 square units, or units squared. Okay, so that's the required area.